We present a combination of ambient multiscale feedback techniques that together provide users with stronger combinations of depth cues to disambiguate static or dynamic abstract 3D scenes. When geometry is shown in its entire context, spatial relationships between objects are easily seen. However, without full context, they can become harder to determine. Often motion is used to help clarify the 3D layout. In static scenes, ambiguities are more noticeable. This is even more apparent in parallel projection. In a virtual world, not all real-world depth cues can be used explicitly. In particular, occlusion, relative size, and height in the visual field are most effective when real-world assumptions such as a consistent ground and normal human viewpoints hold in a virtual environment. We attempt to provide a solution for 3D scenes of any scale and displayed in either parallel or perspective projections in an authoring application setting. A multiscale grid is the primary reference object. It will subdivide or coalesce grid lines in order to display a comfortable number of divisions at any scale, and these updates will be made ambiently, even during zoom, pan, and orbit operations. The secondary reference objects are the position pegs. They serve as lightweight links to the primary reference grid to help users quickly discern relative height, distance, and size information. Each position peg has a fixed size base, an inner disk that is thickened as the object nears the grid, a small cone in the center of the base that points up towards the object, and a stalk that reaches up to the object. Without position pegs, we lose a fair bit of depth information, and without the grid, we lose even more. Relatively small changes in scale are not reflected in the position peg feedback. However, through peg aggregation, when a number of objects occupy a relatively small space, their pegs merge into a different colored peg, with branches along the stalk to the individual objects that are now referenced. A critical part of our design is to assist scene interpretation in parallel projection, where depth information is intentionally sacrificed for consistency of size. By tinting the grid, we can help differentiate which objects are above or below the grid, and by fading the grid lines, we convey whether the viewpoint is from above or below the grid. By adding position pegs, we can now also discern relative position and height. By designing feedback that is both ambient and multiscale, we greatly increase the number of 3D scenes, viewing conditions, and navigation situations that can benefit from the combination of the reference grid and the position pegs.